And our project for this semester is pulse oximeter with other system. So first of all, let me tell you what pulse oximeter is. Pulse oximeter is a medical device that will detect the oxygen saturation in our blood. So if the oxygen saturation goes low, either the person will get unconscious or may eventually die and get paralyzed all of the rest. So when the oxygen saturation goes low, like it's very big concern because according to World Health Organization statistics, there are since 2004 there are thousands of deaths due to unattended patients in the hospital. So our pulse oximeter with alert system comes into play at that time. When a doctor or a nurse can be with a patient for 24/7. So our pulse oximeter will send a text message alert to a doctor or nurse or medical representative when the oxygen saturation goes below the normal level. Here, the normal level we are talking about is about 95% saturation. On the other hand, the advantage of our pulse oximeter would be cost efficiency. We are in the pilot phase right now, and we are building the prototype. And when the prototype will be completed, it will be under $70. That's our estimate right now. However, if you go to market and get a pulse oximeter with alarm or the alert system, it will cost you from $500 to $1,200. Those are very expensive. So let me talk about how the pulse oximeter works. Pulse oximeter, there will be red and infrared light that will be projected on one side of the finger. From the other side, there will be a photodetector. So some of the lights will be observed inside our finger, and on the other side, the remaining light will be detected by the photodetector. From the photodetector, the signal will be filtered and amplified and sent it to the microcontroller. Inside the microcontroller, we will convert the analog signal to a digital signal, and the processing will occur, and we will get the ratio of the amplitude of a red light and the infrared light, and it will be compared to the gold standard, and we will get the oxygen saturation from there. When saturation is low, it will send a text alert to the medical representative. For this semester, we have accomplished until we are now ready to send the signal to the microcontroller. So we get this signal right here. That's the top. The bigger amplitude is the infrared, and the lower amplitude is the red light. This concept can be used in other medical devices to save thousands of lives as well. So if you have any questions or concerns, please feel free to ask questions, or you may join us during the process later on.
Did you base your design on existing reference designs, or did you build everything from scratch yourself?
Actually, we learned from the all existing design and we study it, but we built everything from the scratch.
So, I guess, what was the main advantage that you saw in building everything from scratch as opposed to using existing reference designs to solve the problem?
Actually, our main goal is, like you mentioned, we have to transmit the data, but at the same time we are waiting for the Arduino microprocessor. Sometimes we can learn more about the pulse oximeter, how it works, so that what kind of frequency we should use to transmit and all this stuff. So we will get a better understanding, deeper understanding for the pulse oximeter. That's what we did from the scratch.
How big is the system?
It's pretty small, but we are using individual chips. That's why it's look like this way shape. But if you combine if let's say we need maybe, for example, NOR gate, we need one NOR gate only, but in the package is 8 NOR gate, so it's kind of low a little bit compared to the market. But we have, but if we follow and line.
So you have your prototype out here?
We do have this. Okay.
What kind of, you're using a photodetector pair?
Yes, sir.
They have to be matched?
Yes, because we're using the red light is a 660 nanometer and the infrared is 940 nanometer. So we pick the photodiode within that range.
You use it on the finger, right?
Yes, sir. Yes, sir.
Are you planning for a wireless oximeter or wired?
For the data processing is a wire to integrate the microprocessor. From the microprocessor to the cell phone is process we're using for this transmitting systems.
What kind of transmission from the microprocessor to the cell phone?
To the cell phone.
Bluetooth?
No, actually it would be a text messaging system. We are using an Arduino microcontroller, and they have the GSM still with that. So we will have a SIM card on it, a regular working SIM card, and it can transmit text messages from there to anywhere.
Oh, I see. Okay, so you have a cell phone subscription that you sign up for.
For our
You mentioned big wire.
yeah, actually, it was the pulse oximeter. I mean, actually, it was Dr. Patis I gave the pulse oximeter, and we decided, and then we went over it, and then he had another idea before, so we used the pulse oximeter, and we researched all together right now, and circuiting thing, yeah, and obviously the circuiting, and did more about the controls and the research.
Last question.
Do you have any testing set up for phase two? Who are your customers you're going to test?
Oh, for the testing, we can test by ourselves right now, and then we can
see the oxygen saturation very quick. If you don't wait for like about 10 seconds, you can see the differences. Like you can see the minutes tracing, and you can check with it. But we don't have any test situation.
You have to compare it against some standard.
Oh yeah, yes sir. We already bought one.
We already have
That's the gold standard actually.
Just one quick question. Where do you, in the system, where do you see the major challenge ahead of you?
Maybe it's supposed to use the microcontroller, and since we are getting the same signal, and there will be magnitude for red and infrared, so finding out which one is which with the microcontroller would be a challenge. We have to work on that.
Thank you very much, sir.
Right, thank you.